Howdy Pre-Calc students. It's time for another exciting lesson online. Today, lesson 10.4 on hyperbolas. Here's the definition of a hyperbola: the set of all points in the plane in which the difference of the distances from the two foci is constant. You might remember with the ellipse, we had these two focal points. There they are right there. We were looking at the sum of those two distances being constant. Here with a hyperbola, the difference is constant. And of course the hyperbola is a much different shape, kind of like two parabolas in a sense. We'll study about the parabolas next week, but two parabolas that are opening up in opposite directions. Now here's a picture of, once again, a hyperbola that has a horizontal orientation. And it has two axes, similar to the ellipse, which has the major and the minor axis. The hyperbola is slightly different, though. The major axis is sometimes referred to as this transverse axis. And the conjugate axis, there's that funny word conjugate again, kind of like the ellipse's minor axis. So generally we will refer to this transverse axis with a's, like a squared, and the conjugate axis is b and b squared. Now we'll probably use most of all the minor and major axis terminology, although a key thing to remember is that with hyperbolas, the major or transverse axis isn't necessarily longer than the minor or the conjugate axis. We'll see that as we go along here with some of our problems. Also, it has asymptotes. That'll help us when we graph these things in just a little bit. Once again, we have standard form. That's the form we like to get things in. Notice the main difference between hyperbolas and ellipses is right here, that negative sign. Otherwise, this would look very similar to ellipses in the format. Notice the horizontal orientation starts with X. The vertical one starts with Y. So X is a positive term here if it's going to be horizontally orientated, and if it's going to be vertically orientated, Y will come first. Again, we're trying to get it in this form. Start doing some graphing. Once again, you got to know your ABCs when we graph these conic sections. With the hyperbola, though, it's a little bit different. This time it's c squared equals a squared plus b squared. So that tells the relationship between the foci and the vertices, as we saw when we did ellipses. So slightly different. This is the same as the Pythagorean theorem, as you might recognize. Alright, let's actually try to do a little graphing here. So here is something that's in standard form. We can tell right away that it's going to have a horizontal orientation because this x term is first. Now, how are we going to graph this? Well, once again, a hyperbola has a center. In this case, that center is going to be at 2, -3. So let's see if we can find that. Here's 2 and -3, which is going to be right about there. Okay. We can tell that our a squared is 36, and our b squared is 4. Again, a squared always comes first when we graph these hyperbolas. So that means that a is 6 and b is 2. Once we find a and b, we're going to use those to do some counting. That'll help us as we graph these. So a is 6. So that means I'm just going to count 6 from that center. So if I was at 2, 2 plus 6 is 8. So I'm going to make a little dash there. And 2 minus 6 is -4, right there. Now, rather than make a line like I did before, I'm going to actually make, kind of some dashed lines like this. And you'll see why here in a second. With my b value, I count up 2. And I make a little dashed line like that, and down 2, a little dashed line like that. So what I've really made here is you can kind of see I've made a little rectangle in the center there. I am now going to draw my asymptotes. I'll try to draw these in a different color here for you. I'll make them in yellow. Might not be able to see these that great, but my asymptotes are going to go through here like this. Notice they go through the center. And we can find equations of those asymptotes, but mainly they're for our help now in graphing this thing. Alright, now when I actually come to graph this hyperbola, I know that because x comes first here, that it's going to have a horizontal orientation. So here's how I graph it. My vertex point is actually going to be right here. And so I'll draw it out like this and this. Same thing over here. Here's my vertex point right here, and so I graph my hyperbola like that. So kind of a fun thing to graph. It's a little bit more challenging than the ellipse for sure, but it's got some of the same characteristics. Once again, as just like with the ellipse, we have general form. Looks very similar to the other general forms that we have noticed before. But here's the key thing. The definition says that A and C, those are your coefficients of the x squared and y squared, those have to have different signs. So even though there's a plus sign here, it might not always be that way. In fact, it wouldn't ever be that way if you had a hyperbola. One of these would have to be negative, either A or C. So what I was trying to get at here is that the general form will always have a negative sign in it. This is how you'll be able to distinguish between hyperbolas and the other conic sections. Alright, let's see if we can try this one. This will be a bit of a challenge, so buckle your seatbelts and let's see what we can do here on this one. You can see that this is in that general form, so once again we're going to have to use our completing the square idea. The other thing you might notice is because the y squared is positive and the x squared is negative, that this is going to be a hyperbola that's going to be orientated vertically. We'll see how that works. Once again though, let's see if we can group our y's together as we've done before, and our x's together. So we have negative x squared plus 4x, and then all this is going to equal negative 28, like that. Now completing the square, again, kind of tricky because of the number in front, so we're going to do a little factoring here. So I'm going to factor out this 4, so it turns into y squared plus 4y. I'll leave a little blank there. I'm going to put a minus sign here, and then I actually have x squared minus 4x. So now I'm going to complete the square like I often do here. So when I complete the square in here, yeah, half of 4 is 2. I square that, so I'm going to actually be a plus 4 in here. If I complete the square here, it's going to turn out the same way. I should have put this inside here. I'm going to have to add 4 there too as well. Now once again, here's the tricky part though with completing the square. It looks like I added 4 here to this side, right? But what did I really add? 4 times 4, so I really added 16. So that is kind of a sneaky thing we got to watch out for. So I'm really going to add 16 to this side. Apologize for the not very good spacing there. Now meanwhile over here, again this should be in parentheses, it looks like I added 4 here. However, because of that minus sign right there, I really subtracted 4 is what I ended up doing. So I want to make sure to do that on this other side as well. And so I'm going to, let's see. Yeah, so I'm going to be actually subtracting 4 there as well. All right, so let's see if we can complete the square and see what we end up with here. I'm going to go back to my blue marker here. So I end up with 4, and then I have y plus 2 squared minus, and then in this case I have x minus 2 squared. And meanwhile, what am I going to get on the other side here will be negative 32 plus 16 is actually going to be 16, I think, right? Like that. Yeah, so that looks good. And now to get it in that final form that I like, remember I always like to have it equaling 1. I'm going to divide everything by 16. And so my final form then is going to be, whoopsie, I don't want that squared thing there. Maybe I can see if this eraser will work. Yeah, there we go. Okay, so I want y plus 2 squared minus x minus 2 squared equaling 1. And I have stuff in the denominator too. 4 goes into 16 4 times, and I'm going to have a 16 there. Now if I graph this thing, I see that my center is actually going to be at 2, negative 2, like that. And this time on my y-axis, I'm going to count up 2 and down 2. So it's going to be right on the axis here. And down 2 will take me to negative 4 down here. Apologize for the poor graphing. And on the x-axis, it's going to be over 4. So it's going to take me right there and right there approximately. Again, I'm going to draw my asymptotes in here. Like that. And finally then I'm going to graph my hyperbola. Remember that because y squared comes first here, it's going to be orientated like this and like this. And in class we'll work on trying to identify the foci and the vertices and stuff like that. Remember that this is hyperbolas, not to be confused with the English term that you have learned about, hyperbole, which is an exaggerated statement. Here, there's my cat Puma, right there, as you can see. But anyway, this is the old statement, it's raining cats and dogs. And here's, of course, what happened when I went to school. Everybody knows that I had to walk uphill to school both ways, as you can see, when I went to school. Now, that's not a hyperbole. Anyway, we'll see you guys tomorrow, and thanks for watching. Bye now.